Okay, this is our binomial theorem for expanding a binomial. Binomial's two terms. Remember last year we learned how to do this with Pascal's triangle. And this is nice for smaller ones. So we'll do an example using Pascal's triangle, and then we'll use it with the combinations up here. The formula is given on 714 in the book. So we're going to start with something simple like x plus y to the fifth. Now, I'm using the sixth row, actually, of Pascal's triangle, but the fifth, it's the one with the 5 in it. So it always starts with 1, first thing to the fifth, plus 5. Now we're going to do descending order on the expansion, y to the first. Yes, I don't normally write y to the first. 10. I'm just taking these coefficients, 1, 5, 10. The next one is also 10. From my line here on Pascal's triangle. So I'm getting my coefficients. And the outside is always 1. And x to the 0, y to the fifth. I didn't write a y to the 0 on the first one. But if you want to think of it like y to the 0, which is just 1, you can. So now we're going to do this with a little more complicated thing. This one might take me a couple of lines. First thing, I'm not going to expand Pascal's triangle. I'm going to do it with combinations. And I'm going to use a calculator to calculate all of my combinations. So now n choose 0 is just always 1. But when I do this thing to the 8th, I need to take the total 2x to the 8th. Now I'm going to do n choose 1, which is just n, which would be 8 in this case. 2x to the 7th times negative 3y. Plus now I get to do n choose 2. So I'm going to do n choose 2 on my calculator, which is 28. So that's 8 choose 2. And right underneath that, that's 28. That'll help me for future reference. 2x to the 6th. Negative 3y squared. Remember, I've got to square the whole sets of parentheses. 8 choose 3. Which happens to be 56. 2x to the 5th. Negative 3y to the 3rd. 8 choose 4. Which happens to be 70. 2x, not plus, that's times 2x to the 4th, times negative 3y to the 4th. Yes, this is tedious. 8 choose 5, which I know these things on Pascal's triangle make a shape. We got 70, this is going to be 56. They are symmetric. 2x to the 3rd now, negative 3y to the 5th. plus 8 choose 6, which is going to be the same as 8 choose 2. 2x squared, negative 3y to the 6th. 8 choose 7, which is 8. 2x, negative 3y to the 7th, plus 8 choose 8, which is 1. 2x is to the 0. I don't really need that. Let's just get rid of it. Negative 3y to the 8th. So now I start multiplying. 2 to the 8th is 256. X to the 8th. 2 to the 7th is 128 times 8. So what I'm doing here in my calculator is 8 times 2 to the 7th times negative 3. Negative 3,072 x to the 7th y. So now I'm going to do 28 times 2 to the 6th times negative 3 squared. And that gives me a positive 16,128. Make that a little neater. 16,128 x to the 6th y squared. Plus, now I've got oops, that's not a plus. It becomes a negative 48,384. Yes, these numbers get very large very fast. X to the 5th, y cubed. Plus 70 times 2 to the 4th times negative 3 to the 4th. $90,720 x to the 4th, y to the 4th. Plus 56 times 2 cubed times negative 3 to the 5th. And again, this is not going to be a plus. It's going to be a minus. So that's a negative number. It's a negative 108,864 x cubed y to the 5th. Now I've got 28 times 2 squared times negative 3 to the 6th. Which is positive 81,648 x squared y to the 6th. The next one should be a negative 8 times 2 times negative 3 to the 7th. Which is negative 34,992 x y to the 7th plus negative 3 to the 8th times y to the 8th. 6,561 is negative 3 to the 8th. And that is my binomial expansion. Sometimes it might ask you for, say, the 11th term or something. So take note here. This is the first. This is the second. This is the third. Notice the number here is one behind. So if it asks you for the 11th, this is going to be a b to the 10th. This will be n choose 10. Okay. The term number is one behind. Okay, that should be what you need for the binomial theorem.